Okay, so we're going to start talking about trig functions. So trigonometry is a branch of math that studies angles and angle relationships. Triangles that cannot be solved with the Pythagorean theorem because there's not enough information can generally be solved using trigonometry. So we can use trig functions to find the measure of all the sides and all the angles in any right triangle. We call this, solve the triangle. Completely solve the triangle. And we've already been doing some of that with triangle sums. If you know what two angles are, you can figure out what the third angle is and so on. But now, given a side length, we can figure out what the other side lengths are also. So a trig ratio is the ratio of the side lengths of two sides of a right triangle. We think of a mnemonic, SOHCAHTOA, some old hag came around here to offer apples, is the Disney version. Some old hag came around here to offer apples. And what this does is help us remember that sine goes with opposite over hypotenuse. The SOH. Cosine goes with adjacent over hypotenuse. And tangent goes with opposite over adjacent. So what we have to do is be careful about being consistent whenever we find opposite, adjacent, and hypotenuse. Let's kind of see how this goes. Let's say we're using angle A as a reference. Now the hypotenuse is always opposite the right angle, so we can kind of take the hypotenuse out of the decision. Now we have to deal with opposite versus adjacent. If it makes up part of the angle that you're using as your reference angle, it's an adjacent side. So AC is going to be adjacent to angle A. So we find the hypotenuse first. That's the longest side opposite the right angle. Then with the two that are left over, the side that we can touch, or the side that actually makes the angle up, like we're standing right here, we could touch this with our left hand. That's the adjacent side. The side we're looking across at is the opposite side. Let's look at this from the other corner now. So let me erase this and start over on the other end. So now let's say we're standing at angle B. The hypotenuse is still the side that's the longest opposite the right angle. But now, if we're standing here at B, we can actually touch this side with our hand. This is the side that actually makes up angle B. This is now the adjacent side with reference to angle B. And 4 is the opposite side with reference to angle B. So notice how it switches. If you're at B, the opposite side and the adjacent side are the 4 and the 3. If you're at A, it's reversed. The opposite side is the 3, and the adjacent side is the 4. The hypotenuse is always the hypotenuse. So sine A for this triangle is going to be opposite over hypotenuse. It's going to be 3 over 5. Cosine A, which is adjacent over hypotenuse, is going to be 4 over 5. And tangent of A is going to be opposite over adjacent. That's going to be 3 over 4. Let's move up. So here we have a right triangle, and they want us to fill in the fractions, and we won't worry so much about the decimals for this. We just worry about the ratios. So remember, sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Some old hag came around here to offer apples. So sine of S, here's angle S. Sine is opposite. Now here's hypotenuse. Sine is opposite over hypotenuse, 7 over 25. Cosine adjacent over hypotenuse is going to be 24 over 25. Tangent, which is opposite over adjacent, is going to be 7 over 24. Looking at angle U, the sine of U is going to be the opposite side, which is 24 over the hypotenuse. Cosine U is going to be the adjacent over the hypotenuse. It's going to be 7 over 25. And tangent U is going to be opposite over adjacent. We've got 24 over 7. So notice that these are flipped. Tangent of S is 7 over 24. Tangent of U is 24 over 7. Cosine of U is 7 over 25. Cosine of S is 24 over 25. And sine of S is 7 over 25. So sine of S is cosine of U, and sine of U is cosine of S. Okay, let's move on. Solve for x and y using trig ratios, round to the nearest hundredth. We'll see how we do with the rounding on this one. So we've got a 64-degree angle here. We've got an 11. Now in terms of the 64, which is our reference angle, the 11 is an adjacent side. This is the hypotenuse. And this is the opposite side. So it's very important to kind of get those in first. Opposite side, opposite the right angle is the hypotenuse, and then the side that makes the angle up is the adjacent side. So if we want to find out, say, what y is, we're dealing with 64, we're dealing with an 11, and we're dealing with a y. The 11 is an adjacent, the y is an opposite. Adjacent and opposite goes with tangent. So we would say tangent 64 degrees equals the opposite, which is y, over the adjacent, which is 11. Now when we solve for y, we get y equals 11 times the tangent of 64 degrees. Now, using it, we've got 64 degrees as our reference angle. So using the chart, which is a couple things further on, a couple pages further, we're looking for tangent of 64. That's the third column over. That's going to be 2.05. So tangent of 64 is 2.05. So we're going to go back up, and we're going to do 11 times 2.05. So that gives us 2.05 times 11, 502, 502, 5522, 2 decimal places, gives us 22.55. So that's y. Now we want to find out what x is. So to find out what x is the hypotenuse. We want to try not to use a computed value, use the one that they give us. So we get an adjacent with the hypotenuse involved in finding out what x is. Now adjacent with hypotenuse is cosine. Cosine goes with adjacent hypotenuse. So we would say cosine 64 equals the adjacent, which is 11, over the hypotenuse, which is x. Simplifying, multiply both sides by x. X times the cosine of 64 is equal to 11. We want to solve for x, so we're going to divide by cosine 64. Remember, cosine 64 is really just a decimal. And we get x equals 11 divided by cosine 64. Now if we go to our table, let's see what cosine of 64 is. So 64 degrees, looking for cosine, which is the middle column, we get 0.4384. We'll round it off to 0.44. Go back. So we're going to do 11 divided by 0.44 to be our x. So we have 11 divided by 0.44. We got to move the decimal over 2 places. So we have 1100 divided by 44. We're going to go like 2 decimal places. So it goes 2 times into 110. That gives 88. 98 1 away. That gives 22. Bring down the 0. That goes 5 times. That gives us 220. 0 remainder. So we get 25.0. So x equals 25. So in this triangle that had a 64-degree angle, with this side being an 11, we found out that the opposite side is going to be 22.55, and the hypotenuse is going to be 25 units long. Now, if we needed to completely solve the triangle, we know that's a right angle. This other angle is going to be the complement of 64. This is going to be 26 degrees. And that's what we have for this page.